Hi everyone, my name is Anton Pelcher. I'm an engineer and I've been building fish farms for over 10 years. Today we're going to take a look at the specifics of designing a RAS farm for growing trout. And we will also figure out the main tricks that will help you design this system correctly. Make sure to watch this video to the end, because watching it will help you avoid mistakes when bringing your trout farm project to life. So here we go. And of course we'll start with the species of trout. 90% of the trout grown in Russia, for example, probably around that, are rainbow trout. So basically, these 90% are just one species of fish, and practically all RAS farms in this country grow rainbow trout. There are also other 10%, and they include different species. We don't take salmon trout, salmon truta in Latin, into consideration. We will now talk only about trout. There is also brook trout or river trout. This is probably the second most popular type of trout, apart from rainbow trout. So in fact, we're going to talk exceptionally about rainbow trout and about the parameters that characterize its farming process, because the other species of trout, starting with brook trout and all species of salmon trout, as well as other species of salmons, have their own characteristics which we simply won't be able to cover in one video. So we will take and consider all the basic recirculating aquaculture systems for growing rainbow trout apart from the rest. Temperature. In general, trout is farmed at temperature range from 0 to 25 degrees Celsius, and this is the temperature range within which it can live. But if we are talking about growing it in RAS, the maximum efficiency is achieved at a temperature of 15–17 degrees. Anything below that is already worsening the growth parameters due to cold water and thus slowing metabolism. If the temperature is higher, its growth parameters are also impaired due to the fact that this is no longer the optimum temperature range. The water is too warm and trout doesn't feel comfortable. Therefore, the optimum temperature for trout farming is 15–17 degrees. Ammonia. The concentration of ammonium nitrogen when on growing fry should not exceed 1 mg per liter, and for grow-out fish it should be no more than 2 mg per liter. This is within the pH range of 6.5–7.5, and observing this range, you will basically have no risk to poison your fish with ammonium nitrogen. Nitrites. Trout is also sensitive to nitrites. It's recommended to observe the value of 0.2 mg per liter for fry and 0.7 mg or maximum 1 mg for grow-out trout. Nitrates. The amount of nitrates contained in water should be no more than 50 mg per liter for fry and no more than 150 mg per liter for grow-out fish. Nitrates are a product of biofilter operation. The bacteria in the biofilter first break down ammonia into nitrites and then to nitrates, so nitrates accumulate in the system and they are almost non-toxic. When reaching the level of 150 mg per liter, fish growth parameters start deteriorating and fish feels uncomfortable, so keep nitrates level within these standards. Carbon dioxide. The maximum concentration of carbon dioxide is 10 mg per liter for fry and 15 mg per liter for grow-out fish. Well, maximum 20, but preferably keep it within the limit of 15 mg per liter. Ensure trout is sensitive to carbon dioxide. Oxygen. At least 8 mg per liter for fry and at least 7 mg per liter for grow-out fish. Feed conversion rate. What is the feed conversion rate, or FCR? It's how much feed we need to spend per 1 kg fish weight gain. So, trout might have different weight and different feed conversion rates. The older fishes, the higher its feed conversion rate is, because of worse digestibility of feed. So for a 300–500 so-called portion fish, the rate is 1.1. Thus we need 1.1 kilograms of feed for 1 kilogram of fish weight gain. For medium-sized fish, this rate is 1.2. Thus if we grow trout up to 2 kilograms weight, the average rate will be 1.2. For large trout with a weight of 3 kilograms and more, it's 1.3–1.35. And for trout which we farm for fertilized eggs, basically now I'm talking about growing it in cages, when fish is grown for 3 seasons before it spawns. The feed conversion rate is 1.45. That is, fish has a large increase in the feed conversion rate in case of growing it to such weight, so 1.45 is the normal feed conversion ratio if you grow trout to get fertilized eggs. Feed. For farming trout in RAS, it's important to use high-quality extruded feeds, specially produced for this type of fish. There are well-known feed manufacturers, mostly they are European ones, for example Coppins, Aller Aqua, Biomar, Legursant, Scretin, Ratio Aqua, and so on. Using such feed helps to achieve a high fish meat quality, a good feed conversion rate, which in principle outweighs their rather high cost. Stocking material. As with all fish species, it's either fertilized eggs or fry. But of course, there is also an intermediate stage, the larva, but we won't take it into consideration now. So the fertilized eggs of rainbow trout are mostly shipped from abroad, from USA, Italy, France. The major suppliers of fertilized eggs are located in those countries. Basically, all fish farmers from the Republic of Karelia in the north of Russia order fertilized eggs from those countries, and also Finland. Fry. Well, fry is a kind of derivative from the fertilized eggs. There are farms where they incubate fertilized eggs and grow larvae up to the fry with the weight of approximately 10 grams and sell it to other farms which grow it to the grow-out fish weight. Basically, it can be done in cages and in RAS. Survival rate. Survival rates are divided into several stages. So the first stage is incubation. During incubation, not all eggs hatch out. Of course, there is waste. The normal incubation survival rate is 85–90%. Next is the stage of larva. The larva is sustained, raised to flood, and then transferred to dry feed. Here we probably lose somewhere around 15%, so the normal survival rate at this stage is 85%. Next, when ungrowing larva to fry, this rate makes another 85–90%. When growing fry to grow out fish, we lose no more than 10% of the total fish amount. Therefore, if you summarize all together, the normal survival rate from fertilized eggs to grow out fish is 60%, an average that can in principle be counted on. Growth rate. Let's start with incubation. There are two types of fertilized eggs. The first type is eggs which have just been fertilized. They hatch during about a month and a half. And the second is the eyed ovum eggs. Thus you put partially incubated eggs into hatcheries, and in 1 or 2 weeks you already get hatched larvae. The next stage is on growing larvae to the stage of fry, from hatching to 10 grams. I recommend to lay down 3 months for on growing the hatched larva to the fry of 10 grams in RAS. This is the time you adequately need to get 10 grams fry. The next time period is needed to grow your fish from 10 grams to 500 grams. This process takes about 7 months. At optimum temperature, optimum feeding, then in 7 months you get a half a kilo of fish. To grow your fish further from 500 grams to 1.5 kilograms, you need about 4 months. And from 1.5 to 3 kilograms, you need another 4 months to get the final product of 3 kilogram trout. In total, you need about a year and a half to grow your fish from the moment of larva hatching to 3 kilograms weight. And you should keep in mind that it will take this period of time only under intensive farming and optimal conditions, which of course cannot be achieved in open system like cages. And so, let's go further to tricks and recommendations for designing RAS for farming trout. Trout is such a fish that occupies the entire water column. The sturgeon, for example, is a bottom fish. You can stock it only in shallow tanks. But it's not the case for trout. You can make tanks 1, 2, 3, even up to 5 meters deep, as long as it would be convenient to perform any operations with the fish, to feed it, to observe it, and of course, to catch it in the end. In other words, there is generally no limits in regards to the depth of the tanks when farming trout in RAS. Trout is very demanding in terms of water quality. It requires transparent and treated water, and it doesn't grow well in muddy or dirty water. Therefore, it's strongly recommended, and I always unnecessarily include it into RAS for trout, to use ozone, as in this case ozone purifies water, and therefore ozonation at trout farms is very desirable. Trout feces are easily sedimented to the bottom of the tank. Why is it necessary? Very simple. If they sink well, you can easily catch them in sediment collecting tanks. You can provide for swirl filters locating them near fish holding tanks. They will pick up coarse solids, feces and feed residues, and they will not let this sediment and solids fall into smaller particles inside the pipes. And overall, the mechanical water treatment at your farm will operate better and with higher efficiency. Therefore, it's highly recommended to place a preliminary water treatment unit next to the tanks, and it will filter all coarse suspended solids, so that only part of the suspended matters will stay in the system and will be filtered by means of drum filter afterwards. Biofilters. The water in RAS for farming trout is colder than at RAS farms for sturgeon, and even more so for African catfish, for example. That is, water temperature is from 15 to 17 degrees, and the biofilter operates slower. All processes taking place in the biofilter are happening much slower than at a sturgeon RAS farm. I can tell you that about 40% slower. What does that mean? It means that with the same amount of feed, you have to use 40% more media to process the same amount of ammonia and nitrogen. Trout is very rarely farmed for fertilized eggs in RAS. Why? Because you need to grow trout in the system for more than 2 years. You need to provide for artificial overwintering blocks. And what is it all for? For example, on sturgeons, it's practically the same, but sturgeon caviar costs about 10 times more than trout caviar, so it makes sense at sturgeon farms. The question of expediency of such additional systems for trout remains open and debatable. It means that it's necessary to perform the same amount of manipulations and install the same amount of equipment as for sturgeon, but to get 10 times lower profit. Stocking density. Trout is farmed at higher stocking densities than, for example, sturgeons. Inside the industrial systems, the density of grow-out trout reaches 80, 100, even 120 kilograms per cubic meter. And I came across the system with the density of even up to 200 kilograms per cubic meter. Well, I recommended you not to take such inflated numbers. It's sufficient to use the values of 100, 120 kilograms per cubic meter. This is the maximum stocking density for the trout with the weight of 2-3 kilograms. I don't recommend exceeding 50-60 kilograms per cubic meter when growing trout to plate size weight. Although I have encountered such cases and it's really possible, but nevertheless I recommend to stick to the value of 50-60, maximum 70 kilograms per cubic meter for a stable and predictable fish growth. Degassing. Since trout is more sensitive to carbon dioxide than sturgeon and is also kept at high stocking densities, the installation of a degassing system at a trout RAS farm is mandatory and even indispensable. I recommend the degassing system is installed at each and every RAS farm for trout in order to avoid problems with carbon dioxide and dissolved gas pressure in the system. Tanks. There are two basic approaches to the design of the systems for trout farming. The first is conventionally classical, when we provide for round tanks, water treatment system and tie them together with pipelines. Well, in general, that's how basically all recirculating aquaculture systems are designed. And the second approach, let's call it the Danish one, because this approach originally came from Denmark. What does it mean? They make use of rectangular long canals and a water treatment system adjacent to these canals. The entire water circulation is virtually pressureless and with minimal variations. Often circulation is even provided only by means of air lifts rather than pumps. What are the benefits of such canals? Well, firstly, rectangular channels guarantee maximum compactness. Secondly, the minimum heat in the system allows for the installation of more energy-efficient water pumping equipment. For example, airlifts, propeller pumps, but also some other devices. Well, to be honest, these channels certainly have their advantages, but there is a huge amount of concrete work involved. Well, to be honest, I haven't come across farms where they grew trout to large weight and at high densities in rectangular channels like this. If we are talking about a more classical technology, the larva is recommended to be on-grown in trays or tanks. Trays can be 3-4 meters long, up to 1 meter wide and up to half a meter, even up to a meter sometimes in depth, but it's already a little uncomfortable. As far as fry tanks are concerned, I would recommend designing them 3 meters in diameter and 1-1.5 meters deep. And as for the grow-out fish tanks, their dimensions are generally not limited, except that you should keep in mind that you need to work properly with this fish, feed it, monitor its growth parameters, and in general to catch this fish. Therefore, if you are planning to design a huge RAS, you can of course put much large tanks, several hundred cubic meters each, thus making the whole system more compact. Incubators. It's recommended to incubate trout either in the American-type vertical incubators. And what is it? In fact, it's a special stand in which there are several trays placed on top of each other. The water is cascading. The system is very compact, efficient and cool. Indeed, most salmon, trout and fish farms or plants are currently using this type of incubators. The second option is horizontal tray incubators. That is, when you put special inserts or sections equipped with a mesh into the tray. The water goes through these sections, rising and falling, flowing through all the eggs. Usually 4 sections are provided for. They are less compact than vertical incubators, but they are easier to monitor and control, and if you have rather small incubation volumes, this is fine. And of course, there are certain amateurs who incubate trout eggs in vase incubators. I've seen that too. If it works out, well, that's great. Overall, the vase is a fairly versatile hatchery, and it can be adjusted to incubate in practically every type of fish. Fish weights. The design of a trout RAS farm needs to be adapted to various ultimate fish weights. You can grow fish up to 300-400 grams and sell it to restaurants. This means that it's a portion or plate size weight. It requires its own amount of stocking material and its own production plan. The next option is growing it up to the weight of 800, 1200 grams. In general, to be honest, it's a little bit strange. It's not clear what to do with it. But sometimes it's smoked, or sold to tourists, or probably something else. But in general, farming trout to this grow-out weight, it's not widely spread. And the third option is 1500 grams and more. What is it? This is weight that will be perfect for all types of processing. Of course, such fish ends up and can be found on shop shelves in chilled form. You can find 3-4 kilograms trout on the ice. Also, it can be cut into steaks, slightly salted fillets already in vacuum packing, so you usually see it in the stores. So this is the mass segment, which is highly developed in Russia. And in general, the prices for large trout are higher than for relatively small plate-sized trout. The production volume is also higher, because a lot of different products can be made from it. Well, and now just a piece of information, which is probably for those who, so to say, are not just passing by, but for those who are deeply interested in this subject and want to understand the principles of RAS design for farming trout. Generally, I have partly prepared it for my staff, for their training, but why not to share it with you? So here we go. Let's start with the water exchange. The standard water exchange on trout is 2-3 per hour, taking into account the intensive farming. Well, to be more precise, I recommend 1 water exchange per hour for every 30-35 kilograms stocking density per cubic meter. So, for example, if you have 35 kilograms of trout per cube, great, 1 water exchange is enough. But we're not considering fry now, I'm only talking about grow-out fish. If you have, for example, 60-70 kilograms of fish per cubic meter, you already need 2 water turnovers per hour. Well, and if you have 100 kilograms, you will surely need a minimum of 3 water exchanges per hour, as you need to properly supply oxygen to fish holding tanks and timely remove waste products, ammonia, nitrogen, carbon dioxide, suspended solids. I'm not talking about the maximum stocking density now, but the actual density, which is calculated and included into the production plan. You will see what a production plan is and how to make related calculations in a separate video. Drum filter. Based on my practical experience, 40 micron mesh is recommended for fry, 60 micron for grow-out fish. Of course, some of you might insist that a 40 micron mesh should be used everywhere. Others will say 60 everywhere. Someone will probably have a different opinion, but it's normal. We all have different approaches. But based on my personal experience, fry has a small fishes, so the 40 micron mesh works perfectly and filters the water. On large trout, you can put 60, because the amount of suspended solids is bigger. The fishes are large, and they are easily trapped by the 60 micron mesh. Therefore, this is what I recommend for grow-out fish departments. Biofilter. Well, at the temperature level of 15-17 degrees, it certainly operates slower than on sturgeons and African catfish. 1 square meter of biofilm, which is 1 square meter of protected surface area, treats about 0.3–0.35 grams of ammonia and nitrogen per day. What equipment I recommend? We won't dwell on the tanks, so let's move further to water treatment units. Drum filter, moving bed biofilter. I personally prefer a moving bed biofilter because it's a good and stable technology. It's not very large, quite compact, and in general it has many significant advantages. And also it provides additional water degassing. Biofilter operating on sinking media. What is it for? It's very simple. There are small impurities that are not detained by the drum filter, as well as dead biofilm from the moving bed biofilter. So, the sinking media biofilter traps all these fine substances as the water passes through a layer of static media. In this way, you can achieve higher water quality and its maximum transparency. And an oxygenator, of course. There are different types of oxygenators. These are pressure cones, low-pressure jets, and no-pressure systems in general. I prefer the standard classic pressure cones or low-pressure jets, which can help save energy. Water disinfection. While on sturgeons you can still argue about what is better, ultraviolet or ozone, on trout I definitely recommend ozone. Why? Because it makes the water transparent and of high quality. And as I have already mentioned, trout is very demanding in terms of water quality. and additional units such as a heat exchanger. I still prefer to heat the water in RAS in the automatic mode, to use an automatic pH regulation system, which doses the reagent or acid or alkali when water parameters deviate from the norm. Also automatic feeders. You can of course feed your fish manually or automatically, it's up to you to choose. There is also a water parameter monitoring system, which allows you to automatically monitor and control oxygen, pH, carbon dioxide levels, redox and several other parameters in RAS and gives an alarm signal if something goes wrong. And sure, don't forget about the degasser. As I mentioned earlier, degassing unit is a must at trout farms because, first of all, the fish is held at high stocking densities, and the second, trout is very sensitive to dissolved gases and to carbon dioxide. Therefore, installing a degasser is highly recommended. Well, today we've talked about the special aspects and tricks of designing RAS for trout. We've discussed the main trout species, the parameters of farming, and what equipment is recommended to be installed at a trout RAS farm. I hope you like it. If so, please press the like button and subscribe to my channel. It was Anton Pelcher and my channel on how to grow fish and make good money from it. Bye!